Hey guys, so today we're going to be talking about proof by counterexample. So this is a proof technique that is used to disprove statements in the form for all x p of x, or it's used to prove statements that say that there exists an x such that p of x. So say we're given p of x implies q of x. If we want to disprove it, we want to first negate p of x implies q of x, and we want to find one a in its domain where p of a and not q of a is true. But what we're pretty much trying to say is that we can find an a to substitute into this original statement so that this is true, but this is false. So which makes the whole thing false according to the conditional statement truth table. So let's give an example. Okay, so we want to prove or disprove the following statement. For all a's and b's that are integers, if a squared is greater than b, then a is greater than b. So step one, as we said earlier, we want to negate this statement. So this means that we flip everything on the inside. So this means that there exists an a and a b in the integers such that this is not true. So we just negate the whole statement. So this is pretty much the definition of trying to find a counterexample. We're saying that there does in fact exist an a and a b that makes this whole statement false. We know that a squared could be, say, 16, and b squared could be 4, because 16 is greater than 4. A is greater than b. So that means that 4 is in fact greater than 2. So this does in fact hold. But the statement doesn't say anything about a and b being positive or negative integers. So what happens if a is equal to -4 and b is equal to 2? Well, a squared is still in fact 16. Is this saying that -4 is greater than 2? So here is our counterexample. We can see that there exists an a and a b that are integers. A squared being greater than b squared does not necessarily mean that a is greater than b. So that's our proof by counterexample.